Good evening, everybody. This is the 5 p.m. update on March 28th here. Looking at time-lapse here in North Texas of moisture on its way northward. Moving south to north and mostly just cumulus here. Been watching a little bit of the weather here, and let me switch over to our satellite and you can check that out. This shows the thunderstorm activity developing there along the dry line. And further out west, we also have a cold front coming out of the Rockies. And this cold front is way out in this region. We're starting to see some of the low cloud fields coming together up to the northeast. You can see the extensive transverse banding up in the cooler air mass. And that contrasts pretty sharply with the cloud streets. That's these things here. So the best contrast is roughly in this area right here. So I would say there's probably some sort of frontal boundary along Interstate 20 southeast of Dallas. In the Abilene area, it becomes a little bit less, becomes more difficult to find. I can see the transverse banding under here, and earlier we had talked about some sort of front being just north of Abilene up in this area here. So we're kind of looking at maybe two air masses here. I'm hearing some slapback on my microphone. Let me see if I can figure out where that's coming from. Let me know if you notice anything weird going on with the audio. Give me just a second here. Let me get, I think turning down the music here might help. Forgot I still had the music up. Okay. Anyway, yeah, it was mentioned in chat about some chasers, or apparently some chasers might have gotten involved in some sort of accident. I was seeing something come across about an hour ago about a multiple fatality around Spur that happened right here, about 2 counties east of Lubbock. And I'll zoom in so you can see where this is. That accident was about maybe 2 or 3 miles west of there, somewhere in this region. I don't know who it was, and it's probably not my place to really mention, even if I knew it, because of the next of kin thing. And I don't even know if any storm chasers were, we know there were fatalities in the wreck, but I don't know how many were involved, and I don't know of any names. So anyway, that'll come out eventually, I'm sure, this evening. And yeah, that's some unfortunate news there for sure. Let me go to the current weather here. And you can see that we've got some tornado warnings coming up anywhere from Abilene all the way up to Caprock, up to the Guthrie area. There's a zoomed out look. You can see one storm right there. Up near the Memphis area, it's got a tornado warning on it. The other is in the Guthrie area, and then the final one is down around the Sweetwater area. We can check that out right there. Actually, that's just north of Dias. I'm sorry. So let me see if we've got any spotter indications of a tornado on the ground. I'm bringing up this watch box, and we do have a confirmed tornado there. 5 miles west of Dias Air Force Base. Okay, then going up the line to the Guthrie area. This one, we've also got a confirmed tornado on that. And then further up the line towards Memphis, radar indicated rotation. Okay. So in addition to those 3 cells, we also have a few severe cells mixed in. And then we've got this one isolated cell down around Sterling City, so that's going to be another one to watch. We can see here that the Abilene cell is kind of ahead of the line. And presumably if that gets going, it will have some relatively unobstructed access to moisture coming in from the south. This here cells along the western line that has more of a potential to organize into a squall line there. Let's bring up the radar data. There's the current radar picture, and I'm going to grab the latest 5 p.m. data here. So we're just bringing in the synoptic data, the METAR, and a little bit of upper air data. Okay, I'm taking a look at chat just to see who we have here. We have Tree Nelson and Fred Reamer way up there in North Dakota. Andre Gulbis, Kevin McKinney, Mark is here. Grant Leahy, Fred Reamer, Kevin McKinney. I mentioned Fred already. Sorry about that. And Mark. Okay, let's bring up the surface data here. And what I like to look at right about now is where these boundaries are. They should be starting to firm up, and any of this activity on the south end of the line is going to start interacting with that if it hasn't been doing that already. This has the potential to track eastward into the Dallas-Fort Worth area later this evening, so we're especially concerned about any boundaries in this area. Okay, I'd mentioned one possible boundary indicated by the satellite data, and that was right around here. Is that supported by the surface data? I don't know, not really. I don't see anything there. But if we go a little bit further north to around McKinney to Greenville, I think we could place a boundary up here, certainly. So we've got 82 in this region here, contrasting with 72 up in the Durant area. That's a pretty sharp contrast there. Further west in the Mineral Wells area, we go from 79 to 77, 79, and now we drop off. Okay. So we may have a boundary just a little bit northwest of Fort Worth, kind of along a line kind of like that. And then presumably this hooks up with that other boundary that was way out here. We were watching that on the previous webcast, and let me bring that up real quick. Okay, way out here north of Abilene, this is the Mesonet data for 21Z or 4 p.m. This is the latest that they have right now. And this is showing some sort of boundary through this area here. See, we go from 74 around the Dias area, 75 at Breckenridge, 78. And then it falls off as we go north to about 69, 67 in this area here. And there's a bit of a wind shift across that line. So I think we've probably got them along that row of counties, somewhere in there. But really no help from the satellite data. Can't really see anything underneath that. A lot of debris, cloud debris. And nothing on the radar either that I can find. I'll check the spectrum width, and sometimes it shows up on that. Okay, we're going to have to switch over to Dias. Let me do that real quick. So while that comes up, I'm going to grab some water here. Okay, here comes our data from Dias. So what I'm looking for here is any evidence of maybe an east-west boundary in here. I'm trying to just check and make sure I'm not overlooking anything. Base reflectivity, not showing anything here. And sometimes boundaries will show up when they're close to the radar. They'll show up here on the velocity image, but nothing in this case here. One very important skill when you're working with velocity data is being able to read vertical wind profiles at the radar site. And there are products for that, such as the velocity azimuth display, velocity wind profile. You can get that on a lot of web pages. But you can also read this data directly from the velocity pattern here, from the clear air returns. And the way you do that is you find the zero line. In this case, it's going to be the difference. It's going to be right on the boundary between green and red, like that. And then it kind of goes up like that. And there we go. And the way this works is when you're very close to the radar, you're close to the ground. When you go further away from the radar, like way out here, you're up at probably about 1,000 feet off the ground. And then you get out here and you're 2,000 feet off the ground here. So by reading the position of that zero line relative to the radar, you can kind of see what the wind profile is with increasing height. And so you may be asking, how do you read this? Well, this little point that I'm drawing right here, this is going to be maybe 200 feet up. If you draw a line that is perpendicular to the line between that point and the radar, that's your wind vector right there. So your winds are coming out of the southeast in this case. So green inbound, red outbound, wind a couple hundred feet off the ground out of the southeast there. And then 1,000 feet off the ground, they're also out of the southeast in this case. And only a very gradual turn above that. So this is kind of important from a forecasting standpoint, because this is suggesting that we may not have much curvature of the wind profile in the lowest 1 kilometer. Because what we like to see is kind of an S shape to this zero line, kind of like that. And we don't have that today. Depending on the way the hodograph is set up, though, you still can get storm relative helicity if there's speed shear with height. If the winds down at the ground are kind of light and very strong aloft, you can still build shear from that. But it becomes a little more tricky. You have to have... This is better to draw out on a hodograph, but generally you kind of want curvature, and speed shear helps. If you only have speed shear in this case, it becomes a lot more difficult to get that strong storm relative helicity there. Okay, so here's our storms. We have one northwest of Abilene, and we have a tornado warning on that. Let's check out that storm real quick. So this is around Holly, between Anson and Abilene. And we know that the updraft base is going to be in this area right here. This here is the classic forward flank downdraft. And then this right here is the rear flank downdraft area of the storm. And this here appears to be maybe another cell, maybe something developing in the inflow region. But it's kind of in this inflow region, so... Okay, now that we know where the updraft is, let's check out the storm relative velocity. And we're going to have to adjust this a bit. Sometimes with JR level 2, you do need to do this. We'll try bringing this up to 30 knots here. And let's see, that's probably... Let me try bringing that back down a bit. Yeah, I guess that's probably about as good as we can do there to bring out the shear in that storm. And mostly what I'm seeing here is we're seeing outbound velocities right there. This appears to be the inflow into the storm. I'm going to set a dot right there. So we're seeing about maybe 30 knots. If we want to actually read the velocity, we have to go... Let me set this up so you can read the velocity down at the bottom. Okay, so now you can read that. Right down here. That's the velocity, and this is the maximum unambiguous velocity right there. So this right here, I'm going to set that kind of in the middle. I'm going to switch this over to base velocity so we have a ground relative value. And you can see we've got about 35 knots relative to the ground, and that's mostly blowing kind of in this direction. It's going to be kind of southeasterly, most likely, in the storm. And that's what's feeding the updraft. So, not really seeing much of a mezzo on this storm right now. We can take a look at what it looked like earlier. Let me back this up some. So now we're going back where the storm is over I-20, and that's the last frame I have. Looks like maybe a little bit of a circulation right there. I'll put a dot right there, and is that... Yeah. I guess there might have been something there, and maybe some of this other debris got in the way. This may be seeding from a cell further down the line. Okay, so anyway, that's what's going on with that cell. Here's the latest frame. It looks like the storm is looking a little bit better than it did about 15 minutes ago. There's good reflectivity gradients on the south side. And the trend in the velocity... Yeah, see, I think the inflow is kind of picked up in this storm. About 15 minutes ago, we were only seeing about 25 knots. And this has picked up quite a bit there. You see that? Much stronger inflow into the storm here. So this storm may be going through a bit of an intensification phase about now. Okay, what's going on further down the line? I always wonder if any chasers are way down here. This is a bit out of the neighborhood for most chasers, especially those in Norman. But I bet there's probably a few down there. Definitely going to be good photogenic storms down here. Down there on the tail end with less cells around you to get in the way. Further up the line here by Aspermont and Guthrie, looks like things are kind of filling in here. So if I saw that, I would probably be thinking about going down and playing the tail end storm here. But a lot of other cells are springing up. You see that right there and that right there. One good thing about late afternoon is when we get a little bit later in the day, we start losing some of the heating, and that tends to kill off a lot of the weaker cells. So you'll get a window towards early evening where your weaker stuff is out of the picture. And then you get a little bit better opportunities there for going after possible targets. Okay, let me think here. I'm going to check out the chat here and see if anybody's got any questions. What I'm doing here is maybe just kind of a quick 30-minute session, kind of look at some severe weather and talk a little bit about forecasting. A little discussion there about the... Yeah, a few tornadoes have been posted already up on the streams. Excellent. Hopefully those tornadoes didn't cause any damage there. Okay. I think that's probably about all I got for this 5 p.m. outlook. Now, we are going to be watching for some severe potential over the next few hours still as the cells continue moving northward, northeastward. And remember, we do have that boundary somewhere in this area right here. It's kind of hard to tell the exact position, but anytime you have a boundary like that, especially one that has a little bit of temperature contrast along that, that will definitely help intensify cells as they cross over. They can pick up the baroclinicity on those boundaries, and that can help with tornado genesis. I think they've got a new tornado warning on this. Yeah, on that last frame right there, see, new tornado warning. Source, radar indicated rotation, so I think there's spotters out on there watching that base right there. Unfortunately, when you get east of Anson, there's some very rugged terrain out here, so that's going to suck for those trying to chase this storm here. But fortunately, that also means the areas in here are a little bit less populated. Okay. Let's take a quick look at the surface data real quick. I'm going to see if that 5 p.m. data is in from Texas Tech. I'm going to do a refresh. Yeah, it's in, 5 p.m. data. So what do we got here? I'm looking very closely at the Abilene area down here. I see 72 here, 72, 74, 78, 75. I can see the winds are slightly more, well, I should say they're definitely more packed in this area. We got winds about 100 to 120 degrees. And that contrasts a bit with these winds here out of 140 that you see right here. So I think we've got a boundary kind of right in that area. So those storms moving out of Abilene, out in this area right here, that cell right there, that's going to be crossing the boundary, and we may see it go through a phase of some tornado production here. That's this cell right here. Okay, then further up the line, things look a little less organized. And once you go north, up here, you start getting into some of the cooler air. And you can see that here on the surface chart. There's Plainview, there's Lubbock, and here's Childress. And the surface data is showing a lot of cool air up in that area. 63 with winds out of the northeast, 56-degree dew points. And some of that is going to be outflow coming from these cells. So the best air mass is basically this wedge right here. So these cells here, these are in the best position to undergo development this evening. So to kind of recap, this area here, definitely under the gun, and of course the southern cell also bears watching since that's out ahead of the line. And this cell down here, northwest of San Angelo, also has potential. So let's go over to the radar data. See, now we have a very good analysis of the current weather picture. We've looked at almost all the data. So this is where you are in a very good position to look at the model data and if you don't see something, if you see something in the model data that looks kind of weird, that is going to jump right out at you. So here's the high-resolution rapid refresh model. This is the 20Z model. In other words, it's built from data observed at 3 p.m. There you go. You can see that at the very top here. So what do we have here? Let's run this forward. 22Z. Okay, that's the current data. How does the convection look? I'm looking at the, I'm validating the model here, looking at the initialization. And it's showing, yeah, there's a line just off the caprock that looks to be pretty good. The line kind of breaks off around the Guthrie area. That looks good also. The model is not doing quite as well with the Abilene area storms. So a little bit off there, but and I don't think the precipitation is that extensive down west of San Angelo either. Okay, so a few minor errors. But as far as the big picture, this is pretty close to what we're seeing on the analysis. Okay, so what's going to happen this evening? Let's run this forward. There goes the tail end of that line up towards the Vernon area. Then the model is building a lot of convection further down to the south. So in other words, this gap down here starts closing in. So the tail end of this activity kind of shifts down to Abilene towards 7 or 8 p.m. And then it looks like we're building in the second line back here. That's going to be the cold front coming out of New Mexico. Let me run that back and I'll show that to you here. See that right here? That's the cold front right there. So that's sweeping through pretty quickly and undercutting the dry line, and that'll be kind of acting like a big wedge as it moves across the big country, across the Permian Basin and northwestern Texas there. And this is going to be approaching Dallas a little bit later this evening. Now, what is the severe potential on this later this evening? I'm not sure. To tell you the truth, I haven't really looked at that into too much detail. One quick way of kind of building up an idea of severe weather potential is looking at the wind field. Let's bring up the surface winds here. Winds and dew point. There we go. Areas that are in this more backflow, they are going to have better potential for severe weather, especially if they're in proximity to good moisture. And the chart has the dew point plotted on here. So some of the better moisture right there. The purple that you see right there, that's 70 degree temperatures. 70 degree dew points. Yeah, I just had to read the legend real quick. Okay, so those are 70s, and this is all 60s right here. And this right here, these are 65 degree dew points. So you can see the more backflow right here, the better moisture, basically between I-20 and 287 there. 287, I-20, that's the best potential for severe weather this evening. And I was looking at Del Rio down here to the south. This looks kind of interesting also. You got upslope flow here. You got good moisture. I wonder if anything's going to come together in this region right here. Okay, so for our webcast tonight, looks like things kind of shift to the north towards the Red River. See how all these ingredients move north? There's 20Z, 21Z. And then things shift up to the Red River around 0 to 01Z. Okay, so it looks like our potential is going to kind of move up towards the Wichita Falls area, perhaps. And maybe Dallas-Fort Worth here, a little bit less under the gun this evening. So basically what that means is that when that squall line comes out of New Mexico and moves eastward, it's going to encounter this moist air, so you're going to get locally enhanced instability in this region right here. You're going to get lower cloud bases, lower LCLs. That's all good for tornado production. This here, we've got higher LCLs, a little bit more dry, a little bit less cape. So weaker downdrafts and weaker updrafts, so a little bit less severe weather potential here. So yeah, we're definitely focusing on the Red River region tonight. Areas just north of I-20 up to 287 and near the Red River. And it's kind of hard to see, but the squall line is coming through right there. You can see it in the wind field. And then looks like by 5 or 6Z, it looks like we get this moisture axis coming up from Waco into the Fort Worth area. So maybe severe potential starting to go up in this area later, like after midnight. See how that's coming together right there? So possibly, looks like maybe after midnight, maybe a little bit of severe weather potential for the Dallas area. And I think that would be mostly just winds and some hail. I'm not too sure about tornado potential, but you always do get a few along your stronger squall lines. And then things shift eastward after that. And then we're up at 14Z that's tomorrow morning. Okay, just taking another look at this dew point thing here. It's very cool, all this technology we have. I remember even 10 years ago, it was hard to find data with this much detail. I would have to go to Earl Barker's weather page, which is still online. And I would go there into UCAR. But there wasn't all these good convective models with all this detail here. It's really, really outstanding. Okay, one more look at our situation. There's our storms north of Abilene up to Guthrie. So best severe weather potential based on everything that I've seen so far. I think if these can get rid of their weaker cells, if this can start thinning out a little bit, I think there could be some severe weather potential there, especially as it moves into the Benjamin Haskell County areas. And then definitely this cell out ahead of the line. That's got potential there. And like I said, we know that frontal boundary is out in this region, somewhere out here. And let's check if the velocities are coming up in this storm. Yeah, there we go. Getting a couplet developing there. Diameter on that couplet is about 2 to 3 miles. So that's kind of a tight meso. Getting about 22 in, 50 out. Let me adjust this just a tiny bit. Okay, yeah, that looks good right there. Okay, so 52 out and 18 in, so you've got about 70 knots of shear there across 2 or 3 miles. So pretty good meso developing right there, and I'm going to set the cursor right in the middle of that circulation. And there's that rotation right there. So basically it's focused on this area right here, a pretty good updraft. And I bet this is very photogenic. I don't know, I can't remember if there's any roads out here, but you'd probably get a very good view of the wall cloud out in this area. Wall cloud probably somewhere right in that area right here. Okay. Spectrum width a little bit higher in this area here. I don't think we have a tornado on the ground this early. I'm not 100% sure, but this could also be maybe some hailstones coming down, or it could be some debris being picked up by the strong RFD winds. Okay. Let me go back to the chat and see what people are talking about. Is there anything that explains the processing hardware to make these models? I guess Jeff Day is asking about the computer technology. That's a good question. It is kind of hard to find stuff on the hardware side. I think most of the time what they do is they have like a very high power Unix system, or they lease a computer cluster, that kind of thing. Most of these models, they run on Unix now. So basically it's just a matter of getting computer time or getting a good computer facility and loading everything on there. I do know about 8 years ago I was running the WRF on my computer. You can actually download the WRF and run that. I'm not too sure if they have a Windows port, so you probably do have to run Linux, but that's something pretty cool to play around with if you're able to get that going. The only downside of running your own model is you're kind of dependent on the initialization fields from the Weather Service. So everybody is kind of starting from the very same data. So you can't like drop in your own observations from like VAD wind data, from profiler data. You can't fine tune anything. So basically by doing your own model, you're kind of just adjusting the parameters and trying to customize it for your area, and you're trying to localize it and seeing if you can get better results than what you do from the centralized models here. Dallas-Fort Worth area. Yeah, Ryan mentioned Wichita Falls, Dallas-Fort Worth area. Yeah, that's what we're watching for later. And let's see, I'm probably about talked out here. I'll just take one very last look. Anyway, if you have your radar programs, yeah, keep an eye on this cell here around Anson. That could get interesting. And of course the cells out north of that, if those start thinning out like I mentioned, could see some severe weather potential out of that. And I think most of our severe weather potential over the next few hours is going to focus on probably this area right here. Okay, that's about all I got. We're going to do probably one more webcast, maybe around 6:30 or 7, and then we'll do the usual webcast around 8. So have a good evening, guys, and we'll talk to y'all later.